Hi guys, welcome back to the Graphics Guy. Today I want to look at question 5. Now, what you've got always is an object or a figure that gets moved and redrawn then 4 more times. So you draw this and then you redraw it at P1 after it undergoes a transformation. So it gets drawn differently at P1, then again differently at P2, then again at P3, and again at P4. Now, it's always been the case so far that the fourth one is due to a rotation, and the first three has always been, the order changes, but it's axial, central, and translation for the first three. So I'm going to just look there at axial, central, and translation in this lesson. Now, I think an easy way to do this is just draw yourself, I think a T upside down is a good letter to start with. So I'm going to just draw this 30 of a base, and I'm going to just draw it up here, maybe 40 up. 30 up will do fine as well. Okay, so basically we've got a T there, and I'm going to make one corner of it here. That's my point P. So I'm going to call the other end X, because generally when you're doing any of these questions, the shape can be reduced down to Px and an upside down T, like that. Now the size may change, but you can always reduce it down to a T or a line or something like that to simplify the question. Now, there's 3 things we want to practice here now. So there's translation, and 2, I'll say central, and 3 is axial. Now, what I'd like to do in this sheet here now is, I'll just zoom in here a bit, is I'm going to pick some points here now. So if I decide that T there, just pick a random point, and that's going to be P1. So it gets there by translation. Now translation, it never changes angle. Okay, that is the thing to remember. So you move, just have an idea here now, I'll just pause this. So I'm just going to sketch here my shape. Now in a translation, the angle doesn't change. So if it's like that, in the new position, it stays horizontal and vertical. It never twists or turns in a translation. It never changes angle. It always stays the same angle, you just slide it. So realistically, because we know it goes from here and gets redrawn down there, you could actually just, we know the bottom is 30, we know that it goes 40 up, or I think I left it 30 up, sorry. Okay, now that there is the right answer. Beautiful, perfect. The only problem is you were supposed to slide this. So you are meant to have lines showing where you slid it. I'll call them sliding lines. So that was the right answer, but I didn't do it the right way. So if I take another P now over here somewhere, and I'm going to call that P2, the correct way to do this, now we know that it's going to be coming over 30 and up vertical, but the correct way to do it is by saying that's P1 goes to P2, so they all slide at that angle, and just get my compass. Now, if P slides that far, X slides that far, so I can join them. And the top also slides that far. So okay, so there's PX, and I'll call this T for the top. Alright, so like that is it done by the right method. So again, after losing my pen now, I'll just pick a P3 and a P4, and I'm going to translate this 2 more times. So the proper method is if P2 goes to P3, X goes at that angle, and the top of it goes at that angle, and then you must see how far does it move. So if P2 goes to there, X goes to there, the top goes to here, and I can redraw that again. So in a translation, I know this is vertical, so in a translation it just slides. So I'm going to just remind you, you can go along and you know that if you translate that, it's going to be 30 over, here's the middle, and it's going to be 40 up, 30 up. But you will lose marks. If it magically appears here, you will lose marks because you did not translate it, you redrew it. Yes, you knew that it was going to be like that, but you did not show translation the proper way with the sliding lines, or the translation lines as I call them. So that is what you need to know for translation. Now, I'm going to do central symmetry next. Now what we're going to do there now is I'm going to just pick a center here, and I'm going to do a central symmetry off of this first one. Now, a central symmetry, every point goes through the center and the same distance beyond. So once you find the center, every point goes through the center and the same distance beyond. So if P is that far above, it goes that far below. If X is that far above, it goes that far below. So I can join P and X, and finally, however far T is above the center, it goes that far below the center. So that's P, that's X, this is T, and finally there where the T hits, I'll just bring that down through the center as well. So here is my T shape. Now you will notice central symmetry flips it upside down. So translation doesn't, it just moves it around, but central symmetry turns the figure the other way. So what I'm going to do there now is, so that's P1, P2, P3, P4. I'm going to call this P5. And what I want to do now is I'm going to pick another center here, and I'm going to just put it through the center again to practice. So lines through the center, and however far it's at one side, it goes to the other. So I'm going to start with P. So how far is it to the left? That far to the right. How far is T to the left of the center? Same distance to the other side. So that is T. This is P. This is X. Now, so I can join some of these now, so I know P goes to X, and the thing is now I need this center point here where it connects to there, and that is central. So I'm just going to label that's translation. All of these are translations, every one of them. This is central. This is central. Now, what causes a problem though sometimes in central is that's P6. But you might be given the center, or you might be told that this is P7. So now you have to find the center. Okay, now in this case we have to find the center. So I'm going to join P6 to P7, and I need to find the middle of this line. Now it's It's a little bit inaccurate. I wouldn't say it's wrong per se, but like that's 92, so that would be 46 would be the center. But the best way to find the center, really, to show the person correcting it that you know what you're doing, is open your compass more than halfway and swing your arcs. And when you bisect the line, you find the center. And that's a better way to do it, but really, like, it's an accuracy thing. But you know, if you don't like that, it's not really that wrong to just use maths to find the center of it. But anyway, we wanted the center, we now have the center. So now you're back to what you should know. T goes through the center and the same distance beyond. X goes through the center, same distance beyond. And I'm going to first of all find a new position for T. So I've got T, I've got P. I need to find X. So I can join P to X. And then I know that in the middle of PX, which is still 30, and there's the middle of it, and that is my T. So I'm going to practice that one last time. So I'm just going to take P7. I'm going to just pick a point over here. Pick it up here a bit. I'm going to call this P8. So just a random point. So again, join P7 to P8. Now we want to find the center of that. I'll just make that a little bit heavier so that it comes out on the recording. So we want to find the center of that. So we want to bisect this line, open our compass more than halfway, arc, another arc, so that there is the center. So that's exactly in the middle of P7 and P8. That is the center. So T goes through that center the same distance beyond. X goes through that center the same distance beyond. Get your compass. We've got P, so I'm going to get T and X. So that's X, that is T. I can join PX, which is 30, mark the middle, and that is our T. So all of them, that's central, this is central. Now next I want to look at axial, sorry, at axial. So look, axial now is when you have, I'll just adjust this camera again. So we went as far as P8 here. Okay, so, right, I'm going to work from P6 back here again. So it doesn't really matter. So what I'm going to do is I'm going to make the first one a bit easy. I'm going to put just an axis here. I'm going to put the axis in red. So if you have the axis, sometimes you will. Now what is happening here is our T, I need to draw this now on the back. This might help you to understand it. So here is our T and it gets flipped across the line. So you actually end up seeing the back of it at the other side. So it flips across the line. Now, by putting our axis here at 30, when it flips across it, it goes perpendicular, which means these must be at a 60 degree. Okay, so the angle must be 90 degrees between when it flips across. So if you have the axis, you're moving them, the projection lines make a 90 degree angle. So now, however far a point is at one side of the axis, it goes the same distance to the other. So it's similar to central symmetry, but in central it's going through a point, whereas in axial it's flipping across a line. So it's similar but a bit different at the same time. So X is that far above the line at one side, so X goes this far at the other side of the axis. So I'll just mark them. This is P6, P7, P8. I'm going to call this P9. And that's X. And finally, how far is T? That far above the axis, so it goes that far below the axis. So this here is T. So I'm going to draw my shape again. P to X. Is 30. The middle is 15. And the middle goes to T. Now you can see here now, translation never moved the angle at all, and central turns it upside down, but the angle actually, that was vertical. Central flips it upside down, but it doesn't change the angles. Even though I didn't really talk about that because I didn't want to make it too confusing. But axial changes completely. So here was our T, we flipped it across, so we're now seeing the back of it. So it's going like this to like that. So we're seeing the back of it turned upside down. So what I'm going to do here now is I'm going to just pick a random angle for this. So I'm going to pick just any random angle here now. So this is our next axis, and I want to flip this over to here. So it's going to go from being like this to being something like that. So the first thing I need to do is now there's a few ways I could do this, but I need to figure out 90 degrees. What's a 90 degree angle to the axis here? Now you could use the 90 degree angle here, put one end of the 90 along the axis and the other end going through there. That's not a great way now, but like, so what I'm saying is that there is the correct angle, but it's not a great way of doing it. So they'll all be going at that angle, but not a great way of doing it. I'll just move this down here a little bit. Now, what I think is the best way to do it is just use like your 60-30. So just use 2 set squares, or a T-square, sliding set squares as some of you people call them. So get one angle like that, and then once you slide your set square in, this is 90 degrees. So that's the angle we want to use. X is there, P is there. That just shows you that the T was correct. So the axial construction lines, they all make a 90 degree angle. 90 degree angle with the axis. And maybe I should label that. So that's axis. This is our next axis. So again, however far it is at one side of the axis, it goes the same distance to the other side. So that is X. Now, you could actually use maths for this if you like maths, because you would say like that's 22, so it's 44. You could say this one's 52, so it would be 104. So that's T and P 10. So I'll just join that there, but I would recommend just using the compass, because that is how it is meant to be done. So P to X is here, and there's the middle. So here's the middle. So if you're given the axis, the problem is just to figure out what 90 degrees to the axis is. Now, there's P10, but a lot of the time you have to find the axis. So if I say it goes from P10 to, I'll just pick a P11 here somewhere like this. So if I have to find the axis, because I now know that P goes from P10 to P11 by axial symmetry, but I've got to find the axis. So you can always join P to the next P. Now, we're going to bisect that line now. So open it more than halfways, swing our arcs. And this actually is the axis. Now, so that is the axis. And the great thing about finding the axis is when you join P10 to P11, that is the angle for our movement, our sliding lines, or our axial symmetry lines. So that's the angle. So we just have to get that angle. They all go at that angle. So here is how far is x to one side, same distance to the other. How far is t to one side, same distance to the other. So here is px. Here's the middle, and that goes down to t. And there. And we have room for one more go there, so why not? No point in wasting the page. So I'm going to just put the line in, and I'm going to just do one more. No, I'm going to find the angle again. Actually, it's probably a better practice. So P12 is here. So join P11 to P12. Open more than halfways. So this gives us the axis. That is the angle for moving. So I'll just use two set squares here. So that is the angle along here for the axis. So this is 90 degrees. So then, and another way I could find this now, I know x must be further away, and I know that it has to be 30, so I'll just set my 30 off one of the old ones here. There was 30. And the more you know about this, we know from P to X has to be 30. So that's another way of finding it. But you've got to understand the basics of it before you kind of move on to the shortcuts. And I know now that in the center of this is the T, and I could also now use angles if I wanted, because I know that that is the angle of the PX. So I could use the fact that this is 90 to draw it. So the more you know about these things, the better you can be at them, but you have to understand the basics of it first. So this sheet deals with the first three parts: translation, central, axial, and you can quite easily go off and practice that sheet there now for yourselves. And that's good practice for three of them. I will make another video on the rotations. So best of luck with that.